presentation for the assignment 1 of deep learning and its application. Our assignment is the classification on the text data, image data, and the multimodal. This is our landing page. We have 3 members, Trần Anh Khoa, me, Trương Minh Quân, and Đặng Ngọc Anh Quân, and the course instructor is Dr. Lê Thành Sách. Now we go to the assignment 1. We have our data right here: image classification, text classification, and multimodal classification. I will tell you the first thing is the image classification. The baseline of this is a convolution network, neural network, and the advance will be the vision transformer. We structure a report with the EDA backbone, methodology, and evaluation page. First, we go to the dataset EDA. The dataset name is Caltech 2256 with the total image of 30,607 image and 257 class, and which has 256 object categories and 1 cluster class. And the original image size is variable, and we split the dataset into the train subset, the validation subset, and the test subset with the number of 70%, 15%, and 15%. This is the some analysis on the dataset. We can see that over the class distribution that the dataset is very imbalanced. While the largest class has over 800 image, the smallest class just have fewer than 100 image. The size of each samples varies as well, ranging from 100 pixels to nearly 8,000 pixels. And there are other things that you can look into. The preprocessing and augmentation, we use firstly the RGB conversion and the base resize to 256 times 256 with normalization. The training augmentation, we use random resize crop, horizontal flip, and random augment. The validation and test pipeline we use is center crop with split range with data loader being like right here. And here are some of the random generated batch that you can see some sample of the dataset. Next, we go to the backbone. Backbone, we use the ResNet 50 for the CNN and the VIT base 16 for the vision transformer. And this we will compare the local receptive field of the convolution neural network with the global self-attention of the vision transformer. And next is the methodology. We use the loss function cross entropy loss, and we optimize the LMV for both model with the learning rate, batch size, and all this right here. And the methodology here is that we use the pre-trained model to train on with the fully connected layer of ResNet and the linear classification head of VIT. We replace with an uninitialized linear layer matching our target distribution, and all layers are kept unfrozen and updated during training. We also have the seed initialization so that random state are fixed across two grantee data splits and parameter initializations are exactly reproducible. We go to the evaluation results. We can see that, and this is our result. The peak validation accuracy of both image is that of ResNet is 88.5%, and the VIT is 86.4%. And this is the miscalculation pairs of the both models. So we can see that contrary to the general chain where transformer dominate deep learning tasks, our empirical tracking proves that ResNet 50 is the superior architecture for Caltech 256 dataset. It achieves higher accuracy, lower loss, and exhibit more predictable contextual errors compared to VIT. That is it for the image dataset. Now we go to the text dataset.
Quân ơi, share screen. Tắt share đi, tao share chưa? Okay, so finally, the multimodal classification. First is about the overview. So for the data I choose, food 101, I extract the I extract 10 classes from the 101 classes total of the food data set, and comparing few shot with zero shot. For few shot, I experience with uh, 8, 16, 32, 64, and 128 number of shots in the logs increasing space. Um, Here are some of the EDA of the datasets. For the model backbone, I choose VIT, Cliff VIT with batch 32 as the backbone. And for the zero shot, I perform the Brahmin sample, and I also expanded for few shot with learnable context and linear prop. Here are my methodology. So first, I control all everything in the config file, and training the strategy results in this category. You can see here the zero shot win all of the other method, while the learnable context comes second, and the linear props come the last one. here are the Here the structure of the learning loadable context. Basically, you append the loadable tokens before or after the class label, and then passes through the text encoder for training. And here's the evaluation results. With zero shot, the best accuracy is 98%. For the learnable context is 97%, and for linear prop is 97.3%. And overall, the best method is still zero shots, which can really utilize the strength of both text encoder and image encoder. Here are the results from the experiments, and we can view the detailed 1DB reports in this embedded link here. Thanks for listening.